So we're going to start with this one, which is the bright yellow one. And we're going to call that problem number 1. Now here's the thing. We want to find the distance between these 2 points. Now if I had 2 points, and you don't have to write this, you can just look at mine. If I had a point like right here and a point right here, are you looking? I can find that distance easy. Don't write on yours, just look. And I could say that distance too. You know, when you're on the crosshairs, the distance is pretty easy like that. It's like city blocks. And then if I had one over here, then I could say these two, I'd say, well, they're 3 units apart. But what happens is we can get this side if we make it a triangle. Let's go ahead and do that. And you can make it a triangle one of 2 ways. You can go this way. That's the way I'm going to do it. Or you can make it up. If you do all of them, it makes a rectangle. You see what I'm doing? You can either connect, go straight across horizontally, come straight down vertically, or you could have gone straight across horizontally and vertically. You do either horizontally, I don't know if that's a word, horizontally, and you can make it a right triangle. So we can do Pythagorean theorem. But it is very difficult to count boxes, count units across a slant. If we know the hypotenuse says that leg squared plus leg squared equals hypotenuse, write that again. Doesn't hurt you to write that. Tremendously important problem, and there's some neat little facts about it that I can give you later that will help you on the ACT too. Now, all we need to do is find what we know. I think we can find this distance. Can we find that? Well, if you just count your blocks, it's 1, 2, 3, 4. So let's put a 4 down there. And now that -2 is simply that point. I just assume them not put the numbers on the grid because it's a little confusing. So I'm just going to X that out because it's just that point. But these were, I liked them because they were good pictures. And then this is going to be a 2. I think I'm going to write that inside. See, it's 2 on this side. And then we don't know this, which is, you can call it H, you can call it X, you can call it D for distance if you want to. So we want to know the distance between these 2 points. You can take any 2 points and put it on graph paper and connect it and find the 2 legs and do the Pythagorean theorem. So let's plug in. Doesn't matter which leg we do first. I'm going to do this one, 2 squared plus 4 squared equals x squared. Now what's nice about these is you don't have to think about it because you're always looking for the hypotenuse. So I've got 4 plus 16 equals x squared. Now I like the symmetric property. I like my x on the left. So I'm going to switch sides and I'm going to say x squared equals 20. Now make sure you're writing these correctly. To get rid of squared, you take the square root. We were just doing this in Algebra 2 last block. The square root of x squared is x. Now our answer is square root of 20. Will that break down? Let's take 20 and do its factor tree. And I'm going to put the work here because it is your notes. So I've got x equals, see, I've taken the square root of the x squared. So I know x is equal to, and I've got the square root of 2 squared times 5 inside. We can take the square root of that 4 out as 2 and leave the 5 inside. Now, when you get good at it, you can go straight from here and go ahead and take the square root of that and put the 2 out front. Are you looking? If you'll do your factor tree, you can even skip that step. The square root of 4 is going to be the 2, the number you see written twice, and then the 5 is going to be inside. Outside part is rational. We made a big deal about that in Algebra 2 today. And this is irrational. 2 different kind of real numbers that we have exist. Let's do number 2. I'm going to actually stick it over here and do the work on this side. So for some reason, I like to go down. So I'm going to come down and go over. I can do either one. It doesn't matter. So what is this leg? What's that distance? 1. And what's this distance? Count them. 6. Sides of a triangle cannot be negative. You're actually just finding the length of them. So that's a 1 and that's a 6. And then this is our hypotenuse. So I've got, let's see, 1 squared. Oop, I guess I need to scoot over, don't I? 1 squared, that's one of the legs, plus 6 squared equals x squared. Now write that on your notes. You may not write it in your classwork, but I would like to see that in your notes. So I get 1 squared is 1, 6 squared is 36, I get x squared. X squared equals 37, square root, and I get x equals, math class we like it exact, and I get the square root of 37. Will that break down? 37, only thing goes into it is 37, it goes one time. There's no factoring. Remember, you're looking for pairs. The square root of a perfect square, and there's not two 37s, and there's not two 1s. Even if it was two 1s, the square root of 1 is 1, and it's out front. So square root of 37, so you have some that you don't break down. If you're not sure, look at its factor tree.